Hello, good morning, girls. I'm here to teach you economics this morning, and we are going to look at this topic, measures of central tendency. Measures of central tendency. That's the topic, and you know is the part of economics that has to do with what? Calculation. We call it statistics in economics. So what do we mean by measures of central tendency? So for measures of central tendency, we want to look at the measures of central tendency. But before that, there are these measures of central tendency is also known as measures of what? Location. We can also call it measures of location. Measures of location or measures of position or measures of position. They are just the same thing. We can call them averages. They are averages that are in form of what? Single figure. Single figures that give the central or middle value of a set of observation. So we have the 5 measures of central tendency. They are the 5 measures of central tendency are as follows. So one, we have the mean, which is also called arithmetic mean. That's another name for the mean. We have the median. We have the mode. We have the geometric mean. And we have the last one, harmonic mean. So these are the measures of central tendency. But here, we are limited to teach you only 3. The mean, the median, and the mode. So these 2 now, you can meet them in the university. So, but on your own, I would advise you to look at the meaning of geometric mean and harmonic mean. So we are limited to teach you only 3. The mean, which is arithmetic mean, the median, and the mode. So we start. I want us to start with the mean. The mean, remember I said, is also called arithmetic mean. It's also called arithmetic mean. And what is the mean? The mean is defined as the values or the average values in a distribution. How is it calculated? It is calculated by summing up. That's by adding up all the values in a distribution and then divide by the number of what? Items. The mean is represented, it is represented by this symbol, X bar. Don't worry, I'm going to explain more on this. By X bar, which is the mean. So it's either you use X bar when you want to calculate the mean, or you write mean. So anyone. But this is the symbol that represents the mean. We call it X bar, or you can put it like this, X bar. Now, what is the formula for calculating the mean? The formula for calculating the mean, we have mean, or in bracket S bar, whichever one you want to use, equals sum of observation all over the number of observation. Formula for calculating mean. Mean, or S bar, equals sum of the observation over number of what? Observation. Then, if you want to calculate the mean, there are two ways we can calculate the mean. So one, or A, it depends on what is given to you. We have mean, which is the same thing as S bar, is equals to summation x over n. I will explain the meaning of this symbol, summation. The second one is mean, or S bar, equals to summation f of x over n, or summation f of x all over summation f. Now, let me explain the meaning of what I have there. Where I'm going to simplify everything in that formula. Where X bar stands for what? Symbol for arithmetic mean. This is a symbol for arithmetic mean. Symbol for arithmetic, that's the meaning of this. Then, this symbol is a Greek letter. This is a Greek letter denoting sum of. That is summation. Then we have the x. I'm trying to explain what is in the formula. We have the x that stands for the value of series of observation. This is the values of the series of the observation. That is the figures given to you, or figures given. Then we have the summation s. Remember, I'm trying to explain what we have in the formula. This one stands for sum of the values. Sum of the values of all the observation of all the observations given. Of all the observations given. Yn in that formula stands for what? The number of figures or elements or observation. The number of figures or elements or observations. That is the number of the figures given to you, or the values given to you. Now, in the first formula, I want you to look at this first formula. In that first formula, it is used when frequency distribution table is not involved, or when frequency distribution table is not used. While the second one, the second formula, this one, is used when frequency distribution table is involved. So there is a way they will ask you to find the mean of a set of observation. From the question given, you should be able to know whether you are going to use the first one or the second one. But meanwhile, remember that you use this formula when the frequency distribution is not involved, while you use this one when frequency distribution is involved. So let us look at an example on how to calculate the mean of a set of observations. So we have example 1. We can have a question like this. Find the arithmetic mean. Find the arithmetic mean of the following observations. Of the following observations. Find the arithmetic mean of the following observations. What are these observations? We have 4, 6, 2, 1, 5, and 6. This is a set of observations, or this is a set of numbers given, and you are asked to find the mean or arithmetic mean. Now let us look at how we are going to solve it. For the solution, before you start solving any of this, first of all, it is always advisable to write down the formula for calculating that particular question, because the formula will also give you some marks. So we move. So mean, which is the same thing as S bar, you put down the formula. Summation x over n. Why are we using this formula? Because the figures are not many, they are few. And you discover that almost all the numbers here, or just 1 or 2, appear more than once. Now, our mean, therefore our S bar will be summation x. The summation x here is the addition of these numbers. You don't need to arrange or rearrange anything. So we have 4 plus what? 6 plus 2 plus 1 plus 5 plus 6 over 1, 2, 3, 4, 5, 6. The observation is 6 in number, over 6. Therefore, your mean or your arithmetic mean will be, you just substitute what you have here. If you add this one will give you what? It will give you 24. 24 over this 6. So just substitute in the equation. Therefore, mean equals 24 over 6. You apply this formula. Summation x, that is the addition of this over the number, which is 6. Our number is 6. So when you divide, what do you have? You have what? 4 as your answer. That's the mean of the observation. Now, let us go to example 2. Now, example 2, you might be given a question like this. Example 2. The table below shows, let me write down the question. The table below shows the marks obtained by 20 students, in a test. Or it could be in an exam. So what are these figures? So here we have 4, 1, 3, 5, 2, 6, 2, 7, 0, 5, 6. 1, 2, 4, 7, 7, 3, 8, 2, 3. So you can be given an example like this, and the question says, calculate the mean. Calculate the mean using frequency distribution table. Using what? Frequency distribution table. I've already taught you frequency distribution table. We have done it. Then, how do we solve this? Now, if you look at these observations or this set of numbers, you will discover that some of these numbers appear more than once. So it will not be possible for you to start adding straight. 4 plus 1 plus 3 and so on and so forth. So in this case, you use frequency distribution table. But suppose the question did not say use frequency distribution table. Having known this type of observation, you go ahead and use what? Frequency distribution table. Now, our frequency distribution table will look like this. Our frequency distribution table will look like this. We have X. This X here represents the mass obtained. We have frequency. That's the number of times each number appears. Then we have f of x. F of x means frequency multiplied by x. So here we have a table like this. We have a table like this. Now, you come back and look at the figures. Check out the smallest number there, which is 1. You look out for the highest number. The highest number here, I think, is what? 8. The highest number is what? 8. So we have 1. Do we have 2 here? Yes, we have 2, because you have to arrange it in this form. After 2, you ask yourself, do we have 3? Yes, there is 3 there. Do we have 4? There is 4 there. Do we have 5? Yes, there is 5. Do we have 6? There is 6. You ask again, do we have 7? Yes, there is 7. You have done it in ascending order from the smallest number to the highest number. So it is now left for you to ask yourself, how many times does each of these numbers appear? That is the frequency. I've already taught you the meaning of frequency. The number that appears the highest in a set of what? Distribution. Now, you go back to the figures given to you. Ask yourself, how many times does 1 appear? 1 appears 2 times. If I were you, anyone you have taken, just cross. So, 1 appears 2 times. So your f of s means frequency multiplied by what? X. And the x here is the set of observation given to you. So 2 times 1, you have 2. Now 2 appears 4 times. 4 times 2 will give us what? 8. 3 appears how many times? 5 times. 5 times 3 will give us 15. 4 appears how many times? 2 times. 2 times 4 will give us what? 8. 5 appears how many times? 2 times. 2 times 5 will give us what? 10. 6 appears how many times? 2 times. 6 times 2 will give us what? 12. Then 7 appears 2 times. Remember the last figure there is 8, which is the highest. So 7 appears how many times? 2 times. 7 times 2 will give us 14. Then 8 appears how many times? Once. So 1 times 8 will give us 8. You now add. So here, remember, you have to add the total of this f of s first. So you have here, you say summation f of s. When you add it, you have 77. Then here, you also sum the frequency. You say summation f. Our summation f is what? 20. That is all. So when you have this frequency distribution table like this, what do? You now come back to the formula. The formula you are going to use here is mean, which is the same thing as S bar equals, remember this one involves frequency table. So we are going to use the other formula to calculate our arithmetic mean or mean. So here we have summation f of s over summation f over summation f. It's always good to write down the formula before you substitute. Now, from this formula now, our summation f of s is what? 77. So this will give us 77 over our summation f, and our summation f here is what? 20. So when you divide, you have 3.85. This is equal to 3.85. So this is the mean of this what? Distribution. Then I would like us to look at one example also. Let's say example 3 before we go to the next measure of central tendency. Calculate the arithmetic mean. We are looking at example 3. The question says calculate the arithmetic mean for the scores of a student. For the scores of 8 students. For the scores of 8 students in NECO examination. In NECO examination in the year, let's say in the year 1998. The scores are 14, 18, 24, 16, 30, 12, 20, 10. So let's see how we are going to solve this as well. It's also as easy as these other ones. So for our solution, now if you look at the figures involved, you can see that the figures are not too many. You can easily add straight, so no need of using a frequency distribution table. So step 1 there is add up the score. 24 plus. So our mean now should be 18 plus 24 plus 16 plus 30 plus 12 plus 20 plus 10 plus 10 plus 14. That is the scores. 18 plus 24 plus 16 plus 30 plus 12 plus 20 plus 10. 1, 2, 3, 4, 5, 6, 7, 8. You count. 1, 2, 3, 4, 5, 6, 7, 8. That's plus 14. Plus 14. Our n is what? 8. So our S bar, therefore, our S bar, which is the same thing as the mean, you write down the formula you are using, summation what? X all over n, which is the same thing as, when you add up this, you will get 144, then over the number, which is what? 8, over our n, which is 8. When you divide this, you will get what? 18. Therefore, your mean equals what? 18. So that is the mean of this thing. Now, having done this, let us quickly look at the advantages of the mean. The mean has some advantages. Because of time, I will not be able to write them down. So one of the advantages of arithmetic mean. Advantages of arithmetic mean. One of them is that arithmetic mean is very easy to calculate. From what we have done, you can see that it is easy to calculate arithmetic mean. So, arithmetic mean is easy to calculate. It is easy to calculate. The second one is that arithmetic mean gives an exact value. It gives an exact what? Value. It gives an exact value. The third one is that it is the best known average so far. It is the best known average so far. That is arithmetic mean. It is very easy to understand. It is very easy to understand. It is very easy to understand. It provides a good method of comparing values. It provides a good method of comparing values. It provides a good method of what? Comparing values. And the last one there is that arithmetic mean use all the available information in the data. It makes use of all the available information in the data. So these are the advantages of the arithmetic mean. And we are told that anything that has advantage also has some disadvantages. So here we have the disadvantages. Disadvantages of mean. So what are the disadvantages? One, it cannot be obtained graphically. That's one of the advantages. There are other measures of central tendency that you can, obtain from a graph. But mean, it cannot be append graphically. That's one of the disadvantages. Number 2, certain facts in arithmetic mean may not be revealed. Certain facts in arithmetic mean may not be revealed. May not be revealed. It may be difficult to obtain without calculation. Number 3, it may be difficult to obtain without calculation. You can't obtain it without calculation. It may be badly affected. The 4th one, it may be badly affected by extreme values. Affected by extreme values in a distribution. So these are some of the disadvantages of the mean. So we go to the median. Another measure of central tendency, the median. So we go to the median. What do we mean by the median? From the word, median means something in the middle. The median is defined as an average which is in the middle. Is defined as an average which is in the middle. So that's the median. And before you go into calculating median, first of all, you will arrange the numbers in ascending or descending order. Arrange the numbers, that's the numbers given to you, in ascending or descending order. Arranging the number in ascending order means from the smallest number to the highest number. Then descending order is from the highest number to the lowest number. We call it ascending or descending magnitude. Now let us quickly look at an example on how to calculate the median. Now, you might be asked to find the median of the following observations. You have 2, 4, 1, 6, 5, 4, 3. And whenever you are given a set of observations like this, I will advise you to count the number so that when you are transferring to your notes or to your answer script, you will not omit any number. So we have 1, 2, 3, 4, 5, 6, 7. So that when you finish transferring to your notebook, or it will be the same number given to you in the example. Like I said, step 1, the number should be arranged in descending or ascending number. Let us arrange the numbers in ascending order. Arrange the numbers in ascending order. So if we're arranging the numbers in ascending order, we will have something like this. So for the solution, we will have something like this. You go back to the number, get the lowest number there, which is 1, followed by 2, you have 2 there, followed by what? 3, followed by 4, followed by another 4, followed by 5, and then followed by 6. We have arranged the numbers in ascending order of magnitude. Now, when you arrange in ascending order of magnitude, what do? You now determine your n. That is the number of the observation that is in the middle. Now you count 1, 2, 3, 4, 5, 6, 7. What is 7? 7 is an odd number. It's not necessary, I've already done it here. So 7 is an odd number. So that means for you to find the number in the middle, because we are told that the median is the number in the middle. For you to get the number in the middle, if you just want to follow it this way, you can count. Since you have 7, you can count 1, 2, 3. You can put this demarcation. That is how we did it when we were in secondary school. 1, 2, 3. You can put a demarcation and then get the one that is in the middle. So that is one way to do it. But even without putting this, by mere looking at the figures, you should be able to get the middle number there. So our median is 4. That is the middle number in that observation. Then there is another method you can use to determine the median. Or we can use another formula. That is using this formula. What is the formula? N plus 1 over 2. This is another formula we can use to find the number in the middle. That is, with this formula, we can determine the position of median. N plus 2. So here, our n, we are going to use this same example given to us. Let us apply this formula, n plus 1 over 2, to see if we can get the same number. So where you cannot arrange like this and get your median, you can as well use this number, n plus 1 over 2. So here you say our n, what is our n here? Our n is what? 7. That's the number of the observation, is 7. In this above example is 7. So here, therefore, we have, you use this 7 to substitute in this n. That will be 7 plus 1 over 2. This will be 8 over 2. And when you divide, we get 4, the same thing. So either you use this formula or you use the first one by arranging the figures in ascending. You can as well arrange in descending order. So our median there is the fourth position in the observation. Let us quickly look at example 2 of the median. Example 2. Find the median of the following observation. Find the median of the following observations. The figures given are six, 4, 3, 6, 7, 1, 2, 8. So for us to solve this, still on median, we have to arrange these numbers in ascending or descending order. So in ascending order of magnitude, we have 1, 2, 3, 4, 6, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So our n here is 8. Now 8 is an even number. Remember or note that 8 is an even number. Now, since 8 is an even number, what do we do? So to locate the number in the middle, there are two numbers that fall in the middle. Let's say the two numbers that fall in the middle are 4 and 6. Two numbers in the middle are 4 and 6. So to locate the median of the number, you say therefore median equals 4 plus 6 over 2. This will give us 10 over 2. And when you divide, our median will be 5 as the answer. But we can equally use the other formula, the one we used before, by making use of n plus 2, n plus 1 over 2. Now let us still refer to this example 2, and let us use this formula, or using the formula n plus 1 over 2. So here, our n, we should remember that our n is what? 8. So n plus 1 over 2, this is the same thing as 8 plus 1 over 2. This is the same thing as 9 over 2. When we divide, we have 4.5. That's the 4.5 position. So our median should be that number that falls between 4th and 5th position in this distribution. That is how we are going to locate our median. Now let us use this method. Let's say 1, 2, 3, 4, 5, 6. Another 6, 7, 8. Remember, here is the first position, here is the second, here is the third, here is the fourth. If we should go like this, here is the 5th position, here is the 6th position, Here is the seventh position. No. First 5. That is, so what we are going to do here, we have 4 plus 6 over 2, which is the same thing as 10 over 2, and that will give us 5 as well. So our median equals 5. So you can use 2 of them to find the median of a set of what number. So what are the advantages of the median? So we have advantages of the median. What are the advantages? 1, median is easy to understand. Is easy to understand, especially when you don't have so many figures to understand and calculate. Number 2, median is not affected by extreme values. Is not affected by extreme values. Number 3, it can be determined by mere observation. Median can be determined by mere observation. That is, when you look at a set of figures, especially when the set of figures are not many, you can easily, determine the median, the number in the middle. Number 4, median does not involve serious or tedious calculation. It does not involve serious or tedious calculation. Serious or tedious what? Calculation. So these are some of the advantages of the median. So for the disadvantages, disadvantages of the median. What are the disadvantages? The median statistical calculation. Median is not useful for further statistical calculation, or mathematical calculation. That's one of the disadvantages. The second one, the exact location of the median, the exact location of the median, the exact location of the median is sometimes difficult. It is sometimes difficult to determine, especially from a large mass of data. From a large mass of data. That's another disadvantage. The third one is that sometimes it is difficult when you are arranging either in ascending or descending order of what? Magnitude. So, arrangement of data in order of magnitude especially a large distribution. Is tedious. Sometimes it is tedious when you have large numbers involved. The next disadvantage is that you cannot use the median to determine the total values of all the items in the data. It cannot be used to determine the total values of all the items in the data. So these are some of the disadvantages of what? The median. So the last one is the mode. What do we mean by the mode? The mode is defined as the item or the number with the highest appearance in a given set of what? Observation. In other words, we said that it is the number that appears the highest number of times in a distribution. Before this, I've already told you the meaning of what? Frequency. The highest occurrence of what? A number. Now, when you are asked to calculate the mode of any set of distribution, sometimes you may discover more than one mode. And in that case, we call it bimodal. Sometimes you discover more than two modes. In that case, you call it what? Multimodal. So, you have bimodal. You have what? Multimodal. That is when you have more than one mode. More than one mode. Let's say two numbers that appears as mode. We call it bimodal. When you have up to, let's say, three numbers that appears as mode in a distribution, we call it multimodal. Now, let us go to an example. Let us look at an example. Let's say example 1. You might be asked to find the mode of the following data. The figures are 2, 4, 3, 1, 8, 4, 6, 5, 9. You might be given this set of observation and you're asked to find the mode. Now, for our solution, if you look at the figures given to you there, just by me looking at it, you can see that you can easily discover the mode there. And what is the mode there? The number that appears more than every other number there. So through an observation, we can see that our mode is 4. For instance, in this set of distribution, you discover that it is only 4 that appears 2 times. Or, if you cannot discover it, you can just put a small table, X frequency. You start with 1. How many times does 1 appear? Once. You have 2. How many times does 2 appear? Once. You have 3. How many times does 3 appear? Once. You have 4. How many times does 4 appear? 2 times. After 4, we have 5. 5 is also once. We have 8 and 9. We have 6. 6 appears once. Then 8 and 9 also appears what? Once. So you discover that the number with the highest frequency here is 4 because 4 appears 2 times. So from this example given to you, our mode here is what? 4. Therefore, mode is 4 as the answer. 4 is the number there with the highest frequency. Let us look at example 2. The example says, find the mode of the following set of observation. Find the mode of the following set of observation. The figures are 2, 9, 1, 5, 3, 6, 4, 36. I've got you. Find the mode of the following set of observation. 2, 9, 1, 5, 3, 6, 4, 3, 6. So if you look at this set of figures now, you can see that appears 2 times here. Y6 also appears 2 times. So in this case, the modes are The modes are 3 and 6. And that is what we call bimodal. Bimodal. They are the 2 observations that occurs most. They are the 2 observations that occur most. So the modes are 3 and 6, and that is what we call bimodal. So the last example here, before we go to the advantages and disadvantages, that's example 3, still on mode. With the aid of a frequency, the question says with the aid of frequency distribution the aid of frequency distribution, calculate the modal class, from the set of observations, calculate the modal class, meaning you have to calculate the mode using a frequency distribution. Even when you are told not to use frequency distribution, from the figures, you should be able to know that you are to use frequency distribution table. So let's look at the figures. The figures are 2, 1, 2. So this is the set of the observation, and you're asked to use frequency distribution table. Remember, we have been making use of the frequency distribution table. Like I advised the other time, always count the numbers so that you don't miss any figure. Because any figure you miss from the distribution, it will give you a wrong answer. So for our solution, we have our x. We are trying to prepare the frequency table. We have x. The x here stands for the class, the scores. Then we have frequency, which is f. So here, we look at the figures given. Find out the smallest number there, which is 1. And find out the highest number. The highest number there is what? 8. So after 1, do we have 2 in the distribution? Yes, we have 2. After 2, do we have 3? Yes, we have 3. After 3, do we have 4? In the given numbers, yes, we have 4. We also have 5. We have 6, we have 7, and the highest number there is what? 8. We also have 8. Then we have to find the number of times each number appears. That is the frequency. So we start with 1. 1 appears how many times? You go to the distribution. 1 appears 2 times. So 1 is 2 times. You ask yourself, 2 appears how many times? You come. We have 1, 2, 3, 4, 5. So 2 appears 5 times. 3 appears how many times? 1, 2, 3. 3 appears 3 times. 4 appears how many times? We have 1, 2, 3. So 4 appears 3 times. 5 appears how many times? 1, 2. 5 appears 2 times. 6 appears how many times? We have 1. We have 2. It appears 2 times as well. 7 appears how many times? 7 appears 2 times. 1, 2, 2 times. And 8 appears how many times? Once. So 8 appears once. So when you look at the frequency table, you should be able to discover the number with the highest frequency. So looking at this frequency distribution table, the number with the highest frequency there is what? Is 5. I mean, the highest frequency is 5. And the number that has the highest frequency is what? 2. So, for that reason, our mode is what? 2. Because 2 has the highest number of what? Times it appeared in the distribution. So, 2 becomes our mode. So, you say, therefore, mode equals to what? 2. Because 2 appears more than every other number in the distribution. Let us quickly look at the advantages of mode. So we have advantages of mode. What are the advantages? 1, mode is easy to determine and understand. Mode is easy to determine and understand. You can easily determine mode, especially when the figures are not many. Number 2, mode can easily be obtained. Mode can easily be obtained. Mode can easily be obtained with the aid of a graph. With the aid of a graph. So what does it mean? That you can obtain the mode from a histogram or from histogram of the distribution. That is, from histogram of a distribution. Remember, I told you that a mean or arithmetic mean, you cannot determine it graphically. Mode is usually affected by extreme values. The third one, mode is usually affected by extreme. Mode is usually affected by extreme values from a set of an observation. From a set of an observation. From a set of an observation. Mode can be observed by mere observation. The fourth one, mode can be ascertained by mere observation. By mere observation or glance. Especially when a small population is involved. Yes, when you don't have too many numbers, you can easily determine the mode of the set of that observation. Now let us quickly look at the disadvantages of the mode. Disadvantages of the mode. So what are the disadvantages? Mode is not useful. Number one, we are told that mode is not useful for further statistical and mathematical calculation. So mode is not useful for further statistical and mathematical calculation. That's the first disadvantage. Now, another disadvantage is that mode is not a good measure of location. The second one, mode is not a good measure of what? Location, because all the members of the population, all the members of the population are not taken into what? Consideration. Are not taken into consideration. All of them are not taken into consideration. Then the third one there is that when large numbers of observations are involved, mode may prove difficult. Yes. Number three, when large number of observations, that's large number of figures, when large number of what? Observations are involved, when they are involved, mode may prove difficult to be ascertained. Prove difficult to be ascertained. So it may not be easy. So also in mode, large number of the population are not put into consideration. The fourth one, large number of the population are not put into consideration, are not put into consideration, are not put into consideration while calculating the mode. While calculating the mode. Remember, when you are calculating the mode, you're only interested in the number that appears the highest number of what? Times. So the last one there, the fifth one, is that mode may be prone to errors. Let's see. The last one of the disadvantage that's the fifth one, is that mode may be prone to errors. Mode may be prone to errors and misleading. Prone to errors and misleading because it is not a good, because it is not a good representation of the population. Representation of the population. So these are the disadvantages of what? The mode. Disadvantages of mode. Now, you can notice or you can see that we have treated the three measures of central tendency, the mean, the median, and the mode. We have done some examples on them. I've taught you the advantages and disadvantages of these three measures of central tendency. Remember, I told you that the other two, the geometric mean and the harmonic mean, we are not asked to teach you that at this your level. So, but on your own, you can look at it and know what it means. So, having done all this, I think you are good to go as far as the three measures of central tendency is concerned. So I'm happy you have listened and I believe you will understand. So thank you very much till our next lesson.